Hi guys! Today we'll be discussing builder design pattern. Now this is one of those design patterns that I personally took a lot of time to understand. So we are going to break it down to very simple parts and understand. Okay, it is a creational design pattern as the name suggests. We are going to be building things. But let's just start with why do we need builder design pattern and when do we need it? So whenever we are building a very complex object which has a lot of configurations in it, we use builder design pattern. Just remember these two very important points. One is complex object, second is configurations. Let me give you a lot of examples. For example, you're building a vehicle. Now a vehicle can be a car, it can be a two-wheeler or scooter, right? So all the vehicles have a lot of parts to it, right? It's a complex object. For example, there will be an engine, there will be brakes, but the kind of engine that you will use for a car, and even within cars for different companies of cars, and the type of engine that you will use for scooter will be completely different, right? So to build a vehicle, you have to build parts of it. Like you have to build the tires, the engine, the brakes, all of that, and then bring all of those together to create the complex object, right? Similarly, let me give you another example. Suppose you're building a house. Now, house has some common things to build, right? It has a lot of parts. For example, there are interiors, there are doors to do, there is roof, there is the flooring, right? So these are the common things that you will do in all kinds of houses. Now, the house can be an igloo house or it can be a house made up of wood. It doesn't matter. Whatever the house is, these parts need to be built, only they need to be configured according to the house type, right? Similarly, let me give you one more example. This is the example that we will be using for our code. Okay. Now, when we have to build objects like desktop or a mobile, right? So in a desktop, what all things are configurable? There is a monitor, there's a mouse, there's a keyboard, there's RAM, there's processor. All of these things are configurable, right? And it's a very complex object. You have to first build all of these parts and then create the laptop, right? Or a desktop. Now, for example, I have to create an object desktop. How will I do it? You will say just give the constructor, now just pass all of these parts after building them, right? Now suppose tomorrow I have to change the type of RAM only, or say in the constructor I don't want to give all the parts, I just want to give like 4 parts out of those 10 parts. Rest I will keep some default parts, or I don't want to add that. For example, my laptop might have a touch screen feature, right? But my desktop might not have it. So I might want to pass the type of touchscreen I am adding in the configuration, or I might not want to, right? So for all of these possibilities, are you going to write different constructors? One constructor with only monitor and RAM, another constructor with keyboard, mouse, another constructor with all of these parameters, another constructor with touchscreen, another constructor without touchscreen. Are you going to write all of these? No, right? That won't be flexible and readable. I know when I start writing the code, some of you might go like, this is such a long code, and I completely understand it can be overwhelming. But I will show you a diagram and I'll make you understand how we are dividing our entire code design into multiple parts. And that is making it so much more readable and flexible. The code might be long, but it completely pays off because it's very well structured, flexible, and readable. But before we go ahead and I show you the diagram of builder design pattern, let me tell you about the sponsor of the video. Alma Better provides a placement guarantee of 6 to 25 LPA. So, this is not just a certification course but a well designed curriculum. And I know that you must be thinking that if they provide placement, it must be costly. No, you will be surprised to hear that Alma Beta has an effective cost of INR 0. How? They work on the pay after placement model, that is, they get you a job and then you pay them a part of your monthly salary for a fixed duration. They have a built premium network and community of working professionals such as senior data scientists, ML engineers, etc. 200 plus hiring partners, alumni, and students. You get to interact with them, get new opportunities as well as industry insights. Alma Better's curriculum includes capstone projects, personalized one on one mentorship, doubt solving sessions, visual elements, and gamification of concepts. You can also choose between live classes or self paced learning. So go check out the link in the description and don't forget to use the coupon code KIRTI25 to get 25% off on the course. Now let's understand this diagram of builder design pattern and let's see the parts of it. If you understand this diagram, you have understood the entire design pattern and then we just have to see the code. Okay, so our builder design pattern has basically 4 parts to it. The first part is the product or the complex object that we are going to create, right? In our example that we are going to take, the object that we are going to create is going to be a desktop, right? Now there is going to be a builder corresponding to the product, which will be a desktop builder in our case. So our desktop builder is basically an interface. It's going to be an abstract class which is going to tell, okay, these all functions have to be implemented by the concrete builders. I know, let me explain it to you. So there was a desktop builder. Now there are going to be two types of desktops that we are going to build. There is going to be a Dell desktop and there is going to be an HPP desktop. Okay. Now both of them will have their own configurations, their own type of monitor, their own type of keyboard and stuff, right? Now our concrete builders, that is the Dell desktop builder and the HPP desktop builder, these will have to implement the functions that are written in the interface, right? That is the desktop builder. Now it will be like build monitor, build desktop, build keyboard. Now both of these concrete builders, the Dell desktop builder and the HPP desktop builder, these will actually do the building. Okay, they will build their own type of mouse, they will their own type of keyboard, and they are going to build. Okay, the desktop builder is going to tell, okay, you have to build this. Concrete builders will actually use the configured monitor, the configured keyboard, and actually build. So we have seen three parts till now. There's the product, which is desktop in our case. There's the builder interface, which will be the desktop builder interface in our case. And then there will be concrete builders, which will implement the functions in the desktop builder. These concrete builders in our case will be Dell desktop builder and HPP desktop builder. These three parts are clear. Now the fourth component in our builder design pattern is a director. So director is responsible for actual generation of the product. It tells that how these steps will be followed to finally generate the product, the process towards it. So it will say, you know what, first build the monitor, first build the keyboard or the motherboard, and then do this. So it will take care of the entire process. For example, when building a house, our civil engineer is going to be the director. It will tell, you know what, do this. Then we will do those steps one by one. Or in case of building a desktop, the person who is building the desktop will be the director. Now, strictly speaking, some people implement the directors, or some people they actually call the client or the person who is using the builder design pattern itself as the director. So strictly speaking, you can actually call this component as optional because the same code can be written in main itself and then our main actually becomes the director. But to properly explain it to you, I'm going to write the code in a separate director component and I'm going to explain you that how it could have been written in the main itself. Okay, so now let's get to our code and let's write these four components and see how the code works. Again, guys, if it is confusing, it will be clear. Just stay with me, stay patient. It can be confusing, but it will be clear in the end and our code will be super flexible, super readable. Let's get started with the code. Let's start writing some code now and let's get started with writing a product, which in our case will be a desktop, right? So this is the desktop header file. In this, what am I going to do? I'm going to write a class desktop. And in this, what all things will be there? All the parts of the desktop will be there. So we're going to build a mouse, a keyboard, RAM, a processor, all of these things will be there. So let me add that quickly. Okay, give me a second. I have added all the parts of the products. For now, I have given all of them as strings to keep things simple. Otherwise, these all can also be different objects, like monitor can be an object, keyboard can be an object, mouse can be an object, and so on. But for now, for simplicity, I've made all of them as strings, right? What else do we need in our class desktop? So we have these parts of the desktop, but we also need to set these parts, right? Because these are all private parts. So we need setters for these parts. So I'm just going to quickly add public setters. So those setters can be called by anyone. Okay, we are going to see who's going to call them. Now you can see I have added setters for all the parts of the desktop, right? I'm going to add one more function, which will be just show specs. So that will be just to show the output after we have built the desktop that, okay, the parts that I have added are correct. Okay, so I'm going to add another function, which is going to be called show specs of the desktop. Okay. So this is our product, that is the desktop header file, right? I have written some setters in this. Obviously, these setters have to be written, right? They have to be defined. So the CPP file, let me just quickly write these setters and let me show them to you. As you can see, I've written all the setters. So I'm setting monitor, keyboard, mouse, speaker, RAM, processor, and the motherboard. And then I've written the show specs function in which I'm just going to output that, okay, this is the monitor, this is the keyboard, this is the mouse, and so on. So we are done with writing the product class. That is the first component, desktop class, right? What was the second component? The builder. So we are now going to write a desktop builder class. This is the desktop builder header file. So what is going to be there in this? There's going to be a class desktop builder, right? So I'm writing that class right now. And what is going to be there in this builder? We need the product inside this builder, right? So we'll define a product over here. Also keep in mind that a product needs to be accessed by all the concrete builders, which will be inherited by this desktop builder, right? And that's why I'm going to make our product inside this, which will be a desktop, in the protected manner. So I'm going to add a protected section and I'm going to add the product inside this. But to add the product, we also need to include the desktop class in this. So I'm going to include desktop.h. Right now, since I've included it, I can have the product over here. So desktop is here now. Now what we are going to do is in the constructor of the desktop builder itself, we are going to initialize this desktop. So as soon as a builder is created, a product is created corresponding to it. But this is a simple product. This is a simple desktop. None of the parts have been built or none of the parts have been configured yet, right? So we need to add all of those parts which will be implemented by our concrete builders. So now let me add those parts. As you can see, I've made all of my builder functions as pure virtual functions because I've written virtual void and equal to 0, which means all the concrete builders, that is all the classes that will inherit from this desktop builder, have to implement these functions. So they have to build a monitor, keyboard, a mouse. So our desktop can't be just as it is. We need to add these parts to it. That is what I have done right now. Okay. Now the desktop product is over here, right? So I can actually write a getter of the product over here also. Now, some people, while implementing the builder design pattern, what they might do is add the getters in the concrete builders, like in Dell Desktop Builder and in HPP Desktop Builder. They might write the getter of the desktop there instead of writing it over here. That is not wrong thing to do. But in our case, what is happening? We are building a desktop product only, right? Because the type of product that will be developed by both the Dell Desktop Builder and the HPP Desktop Builder will be desktop itself. That is why we can have the getter over here. But for example, we were building, say, car and a scooter, right? They might have like different return types. Like one might be a car type and one may be a scooter type. Ideally, what should happen is that they both are also inheriting from vehicle, and we are returning a vehicle. So in that case, also we could have like a vehicle getter itself. But suppose we don't have that, and our getters have to be separate. In that case, what we can do is write the getters in the concrete builders instead of writing it over here. Now, these are the minute details that can actually confuse people, that, where things are supposed to go in builder design pattern, in which component it is supposed to go. But don't mind into going into so much detail, because the way people implement builder design pattern might be a bit different here and there. This part is not that strict. So we can actually write getter within the concrete builder itself. I hope you have got the point. I'm making it virtual so that in case it is required to override it, it is possible. And I'm returning a desktop pointer. I'm going to call the function as get desktop. And I'm going to return our desktop from here. We are already done with our second component, which is the desktop builder. Now let's finally get to our third component, which is the concrete builder. So we are going to finally write the Dell Desktop Builder and the HPP Desktop Builder. It's very simple. All we have to do is really just implement these pure virtual functions. So let's do that quickly. This is the Dell Desktop header file. In this, I need to inherit from the Desktop Builder, right? So I need to include Desktop Builder. And once I have done that, I can actually write my class, which I'm going to call as Dell Desktop Builder. And I'm going to inherit it from the desktop builder. And I have added all the functions that were there in the desktop builder over here. And I obviously need to write the functions in the CPP file also. So as you can see, I have included the header file in the CPP file. And what have I done? I have just set all of them, right? So right now I was setting strings only. So I have just written Dell monitor, Dell keyboard, Dell mouse, Dell speaker, Dell RAM, Dell processor, and so on, right? So these are strings itself. But in real life, what would happen is that I would actually build the parts over here and configure them. So if I am building a Dell monitor, I would configure over here that I'm building a Dell monitor, right? And in the HP desktop builder, I would actually configure the monitor over here, right? So my concrete builders are for the configuration part. So here I have just passed the strings to keep the example simple. But I'm going to do the same thing in the HP desktop builder to really show you that how it looks. This is my HP desktop builder header file, and this is exactly same as the Dell desktop header file. I have just written all the functions as it is. I'm going to do a similar thing in the CPP file as I did in the Dell desktop builder. And this is how my HP desktop builder CPP file looks. As you can see here, I have configured as HP monitor, HP mouse, HP keyboard, right? The strings I have passed are different from the Dell one. There I was writing Dell monitor, Dell keyboard. Here I have written HP keyboard, HP mouse, right? So here I have configured it in the concrete builder. So we are done with the important three components of builder design, and let's quickly revise it. First, we made the class desktop, which was our product. In this, we just wrote that, okay, what all parts are going to be there in the desktop, okay? And we wrote the setters for those in the CPP file. Then we made a desktop builder. In this, we just wrote pure virtual functions so that our concrete builders know that virtual functions have to be implemented. And we wrote a getter over here that, okay, we need to return the product in this. And in the constructor, we had initialized the product. Okay. So this was our desktop builder. Then we wrote two concrete builders. One was the Dell desktop builder and one was the HP desktop builder. In both of these, all we have done is just implement the pure virtual functions that were there in the desktop builder, and we have configured them accordingly in the CPP file. So in the Dell desktop builder, we sent Dell monitor, and in the HP desktop builder, we sent HP monitor, and so on. Now let's come to our final fourth component, which is the director. Finally, we are at our director component. In this, what do we need to include? The builder, right? So a builder will be sent to the director, and a director will use the builder to create our product. Okay, so we need to include our desktop builder in this. So let me add the desktop builder that I have done. Now I'm going to write the class desktop director. Now in this director, we need builder as a member. See, in the builder there was product, in director there will be builder, and director will use the builder to build the product, right? Again, to keep it very simple, our builder has product, our director has builder, which is going to use the builder to create the product. Simple. So we're going to add the builder member in the private section. So in the private section, I have added desktop builder. So in the constructor of the desktop director, builder will be passed. I just have to assign the member to that builder, right? So let's do that. I'm going to write the constructor desktop director, and it will be passed a desktop builder. So for a parameter, I'm just adding P. I'm going to call it desktop builder, and I'm going to assign my object desktop builder as P desktop builder. Now, what is the main function of the director? It tells the process by which our product will be built, right? So now actually let's build a product in that desktop director. It's going to direct the entire process. Let's see how. So in this, there is going to be a build desktop function, which is going to return desktop. So we are going to write build desktop. So director is going to do the entire thing, right? It already has the desktop builder, and this desktop builder already has all the build functions. So now what I'm going to do is call those one by one and actually build the desktop. So what I'm going to do, build monitor, then I'm going to do build keyboard, and similarly I have built all the parts. And now since in this function I'm returning desktop pointer, I'm going to say the builder itself had a getter, right? So desktop builder had get desktop, and I'm going to return the desktop. Now see another point over here. In this function, I am returning a desktop pointer and I am calling a get desktop, right? First thing to notice over here is I am calling the builder's getter itself, right? The getter that we had written in the builder class, remember, which I was telling that you could write in our concrete builders also. So I am calling that getter over here to actually return that desktop pointer. What some people might do is use this function to just build and not return anything from here that you are building, and they might write a separate getter, right? So I am just writing that getter also separately to show you that how that can be done. So what I'm going to do is I'm going to return desktop. From that, I'm going to say get desktop, and I'm going to use my builders function to return the desktop. So desktop builder and get desktop. To again make it clear, our builder had a product and our builder had a getter of the product also. Now our desktop director has the builder, and now the director is using the builder to get the desktop, and it is building the entire product through the processes. See, these processes are already written in the builder, but the only thing that director is doing is giving it a process. It is actually calling the build processes and building the things. While building a house also, what a civil engineer will do, he or she will tell that, okay, these are processes are to be followed. It will tell the builders, and now builders will actually take care of the configuration part, that I need to build a what kind of roof or what kind of flooring. Here also see, I have just passed desktop builder. Now this desktop builder could be a Dell one or an HP one. It does not matter. What I am going to do is just pass this desktop builder, and I'm going to tell the builder that you add the configuration and then you build the monitor and you give me, and I'm just going to return the desktop, right? Now that we have written all the four components, Let's finally see how our client can use our builder design pattern and how easy it will be for our client to use it. This is the final part of understanding the design pattern, guys. You have actually understood everything. You just have to see how it works. This is the most interesting part, obviously, right? As you can see, I've included the HP Desktop Builder and the Dell Desktop Builder, and I've added the desktop director, right? So let's actually write two types of builders, and let's write two directors who will be given these two different builders and actually build two different products. Let's do that. So let's first use HP Desktop Builder. I'm going to create a new one. And I'm similarly going to write a new Dell Desktop Builder. And now let's write two different directors and pass one of these builders to each of them. So let's write Desktop Director 1. What were we passing in the desktop director constructor? We were passing the builder, right? So we are going to actually pass the HP desktop builder in one, and we are going to pass the Dell desktop builder in the other one. Now that we have two directors, our directors can actually build the desktop. In our build desktop function that we had written in our director, we were actually returning the desktop, right? So we can actually return the desktop. So let's write desktop 1, and it's going to be returned from director 1, and it's going to do build desktop. So we don't need to pass anything over here. See, because director 1 already has the HP desktop builder. So it already knows that I have to build an HP desktop, right? Similarly, let me create one more desktop. So I'm creating desktop 2, and our director 2 is going to build this. And since we have already passed the Dell desktop builder to it, we don't need to tell it again. It already knows that, okay, this is my builder. I'm going to build this product, right? So to really show you what is being built, I had actually written show specs. Remember in the desktop class, we had written show specs. So let me just show you that how the product has been developed now. Let's run it and see. I hope everything works. Right. As you can see, it looks so beautiful. So first thing that we had passed was HP builder. So first HP monitor, HP keyboard, HP mouse, all of these were built. And then the second desktop when it was built, or everything was built from Dell, right? So this is what we have done. So as you can see, we made the entire building of a complex object very simple. For our client, what it had to do, it just had to tell, okay, this will be my builder. And it told the director that, you know what, use this builder, build the object and give it to me. As I had said in the starting, that director is actually optional. So what some people might do is that here what we are doing now, that build this, build this, build this, like build these paths. So instead of writing in the director, some people might write it in the client itself, and they will be the director of directing the entire product, which is fine. In that case, our director is same as our client. What I have done is I have kept the concerns even more separate. I just made a different director and told the director that you build the desktop and give it to me. So I hope everything was clear. Just four components, and we build very, very complex objects. In real life, all the objects are complex. So we know that this is a design pattern that is used extensively a lot. It is very, very useful. Let me know what you think about it. If you have any questions, any doubts, feel free to ask me. Please do give me a feedback also. It will help me improve. I'm going to upload the rest of the design pattern series very soon. And so please stay tuned, and please don't forget to like, share, and subscribe. It will mean so much to me. Thank you.